nuclear physicists have found a new way to use the Relativistic Heavy Ion Collider (RHIC), a particle collider at the US Department of Energy's Brookhaven National Laboratory, to see the shape and details inside atomic nuclei. The method relies on particles of light that surround gold ions as they speed around the collider, and a new type of quantum entanglement that is never been seen before. Through a series of quantum fluctuations, the particles of light, aka photons, interact with gluons, glue-like particles that hold quarks together within the protons and neutrons of nuclei. Those interactions produce an intermediate particle that quickly decays into two differently charged pions. By measuring the velocity and angles at which these pion plus and pion minus particles strike RHIC's star detector, the scientists can backtrack to get crucial information about the photon and use that to map out the arrangement of gluons within the nucleus with higher precision than ever before. This technique is similar to the way doctors use positron emission tomography (PET) scans to see what is happening inside the brain and other body parts. But in this case, the scientists are talking about mapping out features on the scale of femtometers, quadrillionth of a meter, the size of an individual proton. Even more amazing, the star physics say, is the observation of an entirely new kind of quantum interference that makes their measurements possible. The scientists say that they measure two outgoing particles and clearly their charges are different. They are different particles, but they see interference patterns that indicate these particles are entangled or in sync with one another, even though they are distinguishable particles. That discovery may have applications well beyond the lofty goal of mapping out the building blocks of matter. For example, many scientists, including those awarded the 2022 Nobel Prize in Physics, are seeking to harness entanglement, a kind of awareness and interaction of physically separated particles. One goal is to create significantly more powerful communication tools and computers than exist today. But most other observations of entanglement to date, including a recent demonstration of interference of lasers with different wavelengths, have been between photons or identical electrons. This is the first ever experimental observation of entanglement between dissimilar particles. The work is described in a paper published in Science Advances.